So here we're going to be solving equations, and the kind of equations we're going to be solving in this section are linear equations in one variable. So last time, in the last section, we were graphing and working with equations with two variables, an x and a y. Now we're going to be working with equations with just one variable, just x, no y, or it could be a different letter, but just one variable. And we're going to try to figure out, when is this equation true? What number has to go in for x to make the two sides really equal to one another? Now, just in case you're wondering, why do we need to solve equations? When in real life do you ever have to solve and answer some question that you're interested in? Well, let me give you an example from real life, from my real life. So once in a while it happens that it's near the end of the semester. In a class I'm teaching, most of the tests and homework and things like that that determine a student's grade have already been determined, but there's still the final exam to come. And a student comes to me and asks, what do I have to get on the final exam to pass the class, or to get an A, or whatever it is the student wants? So in this example, let's suppose that the course grade is determined by taking 15% of a student's homework average plus 85% of their overall test average, which is the way it works for this class. And let's say that it's the end of the semester, all the homework has already been turned in and graded, and the student has a homework average of 87.2%. And let's say there's been 4 tests throughout the semester, 100 points each, and the student has gotten scores of 92, 86, 63, and 74 on those 4 tests. And then on the final exam, that's going to count as much as 2 of those regular tests. And let's say the student is aiming for a C. The student needs a C to pass the class, which means he or she needs an overall average of at least 70%. So to answer the question, what score on the final would give that student 70% for their overall average, therefore giving them a C for the course? Well, we can set that up like this. We take 15% of their homework average, which is 87.2% or 0.872, plus 85% of their test average. So if we add together all the test scores, 92 plus 86 plus 63 plus 74 plus 2 times whatever they get on the final, we don't know what that is yet, so we'll use an X to stand for that, and divide that by the number of points possible on all those tests. 100 plus 100 plus 100 plus 100 plus 200, so 600 points possible on tests. And that, we're trying to figure out how to get it to come out to equal 70%, 0.70. So look, that is an equation to solve. If we could solve that equation, figure out what number x has to be for that equation to be true, we'd have the answer to the student's question. Okay, so I'm just quickly going to work through the details of solving this. It's a little bit more complicated than the equations I'm going to ask you to solve in this section, but same basic idea. So I could start by, well, I could go ahead and multiply these two numbers together. 0.15 times 0.872 gives me 0.1308. And then I could subtract that 0.1308 from both sides of the equation. So then over here I have a 0.5692. And then I could get rid of the 0.85 out here by dividing both sides by 0.85. So then over here, 0.5692 divided by 0.85 gives me 0.66964708. So there's where I am now. Now what I can do is I can get rid of the divided by 600 part, undo that, by multiplying by 600 on both sides. Then I can add these constants together. Add together the 92, 86, 63, 74. That adds up to 317. and then I can subtract 315. Then I can subtract 315 from both sides, and I get 2x equals 86.788253. Then finally divide both sides by 2, and x comes out to be about 43.4. So in this situation, to get a C for the course, the student just needs 43.4 on the final. That sounds doable. So now the student might think, well, maybe I'm aiming too low. Could I get a B for the course? Could I get an A for the course? To answer those questions, we could go through the same steps, but when we set things up, we'd have a different number over here. Instead of 70%, we could put 80% or 90%, or here I've just left it G as in grade, so that instead of deciding ahead of time what I want the final grade to be, I just sort of leave it as G, and then I can go through all the steps of solving this equation for x. Same steps I went through before, only instead of an actual number like 0.70, I'm just using kind of a placeholder G. But I'm doing the same thing to both sides. I'm getting x by itself, and x ends up being about 352.9 something times G minus 203.66 something. So if you plug in 0.70 for G, you get the answer we got, around 43.4. If you plug in 0.80 for G, so the student wants to get an 80% for the course, then the score on the final exam would have to be about 78.692. And what about to get an A? If I plug in 90%, I get that the final exam score would have to be, well, 113.986. That's not going to happen. Not unless there's a lot of bonus points possible. So C looks pretty easy. B, definitely within reach. A, probably not. So that was kind of a complicated example, but it is an example from real life of solving an equation and using algebra to solve an equation to answer a question that I've actually been asked. Okay, so let's go through the basics of solving equations. Hopefully you already know all this, but let's review it so we know exactly what we're doing when we're solving equations. We know we are allowed to add the same number to both sides of an equation. If the two sides were equal before and we add the same thing to both sides, they're going to be just as equal as they used to be. So we could start out with x plus 10 equals 3. We could add negative 10 to both sides. And then over here, x plus 10 plus negative 10 is just x. And over here, 3 plus negative 10 is negative 7. So that gives us our solution. X has to equal negative 7. And I talked about it in terms of adding negative 10 to both sides, but you could also think, oh, we're subtracting 10, because subtracting a number is the same as adding the opposite or negative of that number. So that means we could also subtract the same thing from both sides. And we are allowed to multiply both sides of an equation by the same thing. As long as that thing isn't 0, we don't want to multiply both sides by 0, because that just kills everything off. But we can multiply both sides of an equation by the same non-zero number, and it stays just as equal as it was before. So if we started with 1/2 x equals 6, to get rid of that 1/2, we could multiply by 2, because 2 times 1/2 times x would just be 1 times x, just x itself. So that would mean that x would have to be equal to 12. And that means that as a bonus, we get the ability to divide both sides by the same number. Because dividing both sides by the same number is really equivalent to multiplying by the reciprocal of that number. So to solve negative 3x equals 12, to get from negative 3x to just x, you could think, well, we could multiply by negative 1/3, or you could just think we could divide by negative 3. And of course, if we do that, we get x equals negative 4. And since each side of the equation is an algebraic expression, we're allowed to do things that are algebraically legal to simplify that expression. Like, if there are parentheses, we can use the distributive property to remove the parentheses. If there are like terms that have the same variable part, we can combine those. When we're solving an equation, we're really looking for the solution set. We're not necessarily looking for the solution because there might be more than one. There might not be any. We want to know what all the solutions, if any, are. So an equation might have just one solution, like x plus 1 equals 4. For that to be true, x would have to be 3. That's the only solution there. An equation might have two solutions. An example of that would be x squared plus 3 equals 4x. That would be true if x is 1. 1 squared plus 3 is equal to 4 times 1. And it's also true if x is 3. 3 squared plus 3 is equal to 4 times 3. They both equal 12. It's possible for an equation to have no solutions at all. X plus 1 equals x. There's no way that could be true because the x has to stand for the same number both places, but there is no number that you can add 1 to it and then it's equal to that same number. And it's possible for an equation to have infinitely many solutions. Like x plus x equals 2x. That would be true no matter what number you put in place of x. 1 plus 1 is the same as 2 times 1. 10 plus 10 is the same as 2 times 10. 37 plus 37 is equal to the same thing as 2 times 37. So this would be true for any real number. So we see there are different kinds of equations. There are equations that are sometimes true, equations that are never true, and equations that are always true. Equations that are sometimes true are called conditional equations. They're true on one condition, or maybe two conditions, but there's certain things that x has to be for that equation to be true. There are only certain conditions when that two sides of the equation are equal to one another. An equation that has no solutions, that means it's never true, is called a contradiction. And an equation that is always true, no matter what number you put in place of the variable, is called an identity. When we're solving equations, usually the kinds of equations we're solving are conditional equations, where we have a solution or maybe 2 or 3 or 4 solutions. But it's possible to get an equation with no solutions or with infinitely many solutions. And if that happens, we need to recognize that and say what's going on. Now, in this section, the equations that we're going to be working with are linear equations. And the word linear here means that there are no exponents on the variable. You'll see x, or we might use a different letter for the variable, but you won't see x squared. If there are exponents, if you have an x to the 2 power or 3 power or something like that, then the equation is not a linear equation, and the approach that we'll go over in this section won't work. Now later on we will see equations like that do involve x squared or x to higher powers. We can solve those, just not by the methods of this section. Okay, I've given you the background. I've laid out what we're going to be doing. So I'm going to end this video here, and then when I come back in part 2, we'll actually start solving some equations.